One important math skill that we need to learn, or you should have already learned, but we need to review, is the concept of completing the square. This is a really good skill to have, not just for pre-calculus, but also for calculus. And really for most maths, this is a really important skill to have and be able to accomplish fairly quickly. The idea is you originally learned completing the square so that you can solve quadratic equations, but the skill of completing the square is used for other things. Completing the square deals with a binomial squared, a plus b squared, or even a minus b squared. And the idea is if I square this, I get a squared plus 2ab plus b squared. Or if it was minus, it would be minus 2ab. And this particular formula is what completing the square is all about. The idea is we're going to start with this polynomial here, and we need to write it as a square. And that process of creating the square or completing the square is what we need to really get good at. So the idea kind of goes like this. If I gave you this piece of the polynomial here, if you wanted to factor this polynomial into this, you would need to introduce this piece. And if I can introduce this piece, then I can take this and write it as a plus b squared. Well, how do I introduce this piece? I have to add b squared to these other two parts. Well, how am I going to do that? I have to know what b is, so I know what I'm adding squared. Well, where am I going to get b from? The only other place b is right here. So this middle term right here is 2ab. Well, if I look at this 2ab, if I can take the a out of it, then I'm left with 2b. And if I then want to figure out what b is, if I divide by 2, I'd get b. And once I figure out what b is, if I just square it and add it on to the end, I can get my polynomial. So how do I get the a away? Because that's really the trick here. Once I get the a out of here, the leftover piece is 2b, you divide by 2 and I get b. How do I get the a? Well, I get the a out, or cancel the a out by knowing what a is. How do I figure out what a is? Well, whatever's being squared here is what a is. So if I gave you something like this and I said x squared plus 6x, and I said this is really in the form of a squared plus 2ab. From this thing, what is a? Well, whatever's being squared here is my a, so in this case a equals x. So if this piece here is 2ab, then if I want to pull the a out so I just have the 2b left over, and then that'll help me find the b, I have to get rid of what a was. Well, a was x. So if I take this piece out of here, then I'm just left with 6. So that means 6 is the 2b, and that x was my a, so I have 2ab. Well, if 6 equals 2b, then if I divide, I get 3 equals b. So now I know what my b is. So if I want to put this in the form of a squared plus 2ab plus b squared, then I need to erase a little bit. Then I have to add b squared. Well, remember, b was 3. So if I add 3 squared onto the end, then this thing is in, this polynomial is in this form, which then means I can factor it as a plus b squared, or in this case, a plus b squared would be x plus 3 squared. Whatever's being squared here is a, whatever's being squared here is b, so x plus 3 squared. So if I started out with this and I wanted to write this thing as a square, I have to introduce this piece. How do I figure out what that piece is? I have to know what b is. So I go back to here, I say, alright, If this is my a, pull the a away. This is 2b. If that's 2b, divide that by 2, and my b is 3. So, what if I said x squared plus 10x? If I wanted to write this as a square, what I would have to do is add something squared onto the end. And if I could do that, then I can write this as a square. So what am I going to do? Okay, then this is in the form of a squared plus 2ab, right? So that tells me that the x is the a, right? So this 10 is my 2b. So if I take the 10 and divide it by 2, that gives me 5. So if I added 5 squared onto the end, then this can be written as x plus 5 squared. How about another one? If I give you x squared plus 7x, I got to figure out what am I going to add squared onto the end. Well, if I look at this and say, okay, this is really a squared plus 2ab plus, I got to get b squared over here. And this piece right here is my 2b. So that tells me that b equals 7/2. This divided by 2. So 7/2 is what I got to add squared on the end. And don't be afraid that it's a fraction. It's not that big a deal. A factor should be a plus b. So in this case it's x plus 7/2 squared. And that's it. If there's a minus, if it's x squared minus, I don't know, 8x, figure out what I'm going to add on to the end here squared. Well, whatever this is, I have to divide it by 2. Well, now that it's negative, I'm going to have to divide negative 8 by 2. I get negative 4. I'm going to have to put a negative there. What happens is that my factors are x plus negative 4 squared, which I'll just write as x minus 4 squared. So the only difference is if this is a negative, this is a negative, because this number is also a negative. So that's not a big deal either. Now there's a catch to all this. One, if you look at each one of these things, the coefficient in front of each one of these squares is a 1. That has to happen. If your coefficient in front of the square isn't a 1, then the x itself is not the a, and then this number right here is not 2b. So somehow you need to make the coefficient in front of the square a 1. Depending on what you're using completing the square for, if you're using a completing square to solve equations, normally you could just divide by whatever this coefficient is in front of here. Like say it was a 3, I could just divide everything through by 3 and I can make it a 1. We're not going to necessarily be doing that. Another way you can take care of it is I can take whatever this is and factor it out. So if I gave you something like 2x squared plus 12x, and I wanted to complete the square on this, what I can do is I could factor the 2 out of these terms. Now if I look at what's inside here, this thing inside has a coefficient of a 1, so then I can complete the square with this piece. In that case I divide the 6 by 2. 6 over 2 is going to give me 3, and I add 3 squared inside those parentheses. Then I could write this as 2 times x plus 3 squared. And that's more what we're going to be using completing square for when we use conic sections. But you know, depending on what you're using completing square to do, you may also want to divide by 2 all the way through. Okay, that's another thing you could do. So when you're doing completing the square and you're looking at these completing the square, ax squared plus, I don't know, say 2bx, right? When I'm looking at this, the idea is that this coefficient has to be a 1, so that I just have x squared times 2bx. This thing right here is my 2b, so if I divide that by 2, I get my b. And then if I add a b squared onto the end, I can factor this polynomial. So that's how completing the square works. Now what we want to do is use what we just learned with completing a square to help us work with conic sections. So what we're going to look at in this is conic sections that are not centered at the origin. So the ellipse, the hyperbola, the circles, the center will not be the origin. For vertex there is no center. For parabola there is no center, but the vertex won't be at the origin anymore for parabolas. Now one thing I kind of left out from the beginning here is that all of these conic sections come from a particular polynomial, and they come from this polynomial right here. We talked about how the conic sections come from those inverted cones and slicing those cones with a plane. So I slice a plane this way, or I slice a plane straight across. This would give me an oval, this would give me a circle. If I took a plane and I cut it through, two of these, I would get the hyperbola here and here. So we talked about the conic sections coming from the two cones, but really those two cones kind of come from this polynomial. This is a second degree polynomial in two variables. So I have an x squared, I have a y squared. I have a mixed term, x times y. I have an x to the first, I have a y to the first, and then I have a constant. So this is a second degree polynomial in two variables. And all our conic sections come from this polynomial. Now some parts of this polynomial end up being 0 to give us certain conic sections. Some parts of this polynomial have to be negative to get us our conic sections. But if we look at the coefficients of this polynomial, a, b, c, d, e, and f, a, b, and c, using this particular formula, can determine what kind of conic section I'm dealing with. If b squared minus 4ac is positive, I would have a hyperbola. If b squared minus 4ac is 0, then I have a parabola. And if b squared minus 4ac is less than 0, I would have an ellipse. So if I gave you 3x squared plus 2xy plus 8y squared plus 2x plus 3y minus 1 equals 0. This is A, B, C, D, E, and F. In that, I'm talking about these numbers here. So if I took b squared minus 4ac, I would get 2 squared minus 4 times 3 times 8. Clearly this thing is going to be negative because this is going to be much bigger than this, and if I take a smaller number minus a bigger number, I'm going to get a negative. So this is going to be less than 0, which tells me that this polynomial is the polynomial that would create an ellipse. Now all that's well and good. Okay, that polynomial creates an ellipse, but what kind of ellipse? What does it look like? Is it a vertical ellipse? Is it a horizontal ellipse? Where's the center? What's the length of the major? What's the length of the minor axis? Well, we can't get any of that by looking at the polynomial as we see it here. So while the b squared minus 4ac gets you the type of conic section you're dealing with, it doesn't really get you much information. But there are different ways we can take a polynomial in sort of this long form, this second degree polynomial in long form, and write it in a particular way that will allow us to figure out, okay, what kind of conic section do we have? It's an ellipse. Alright, where is the center of the ellipse? How big is the major axis? How big is the minor axis? Which direction should we go for those things? We could get all that information out of this polynomial if we would just write it in a different way. And essentially what's going to happen is completing the square will help us do that. So what we have to do is we have to look at new versions of our formulas to take our conic sections and make them so that the center is no longer 0, 0. Originally we would have these two equations. 4ay equals x squared and 4ax equals y squared as our two parabolas. This would be a vertical parabola and this one would be a horizontal parabola. So this one versus this one, because of which one's being squared. And then once we figured out what A was, we could figure out where our focus and our directrix were. Now the center for these parabolas was 0, 0. I could write these equations like this. 4a times y minus 0 equals x minus 0 squared. That's the exact same equation. Y minus 0 is really just y. X minus 0 is just x. So it's the same. 4a times x minus 0 equals y minus 0 squared. It's the same equation. But writing it this way, you see where the center comes into play into the equation. Well, if we want our center to be in a different location instead of 0, 0, maybe I could write my equation like this. 4a times y minus 2 equals x minus 1 squared. If I change these two numbers, that should change my center. In that case, it will. Instead of 0, 0, I'm going to have a center of 1, 2. The first part should always be with the x. The second part is always with the y. It doesn't matter which one's squared. But that's how we're going to change our center. So if we start to look at a new version of these formulas, these are the new versions of our formulas for a parabola. Still only one square, but we have 4a times y minus k equals x minus h squared, where h and k are going to be our centers, or in this case our vertex for the parabola. Same thing here, x minus h, y minus k. hk is the vertex for the parabola. So it's relatively the same form as what we were working with previously, but since we changed where the vertex is located, we changed the equation slightly. Now remember, let me erase some of this. When we look at a parabola, that a value is very important. In that when we would draw, say, a vertical parabola like this, if our vertex was here, a would tell us how far to go that way to get my focus, and a would tell me how far to go that way to get my directrix. Well, that's fine. If our center is no longer 0, 0, but hk is our vertex, and I think I keep saying center for a lot of this because, you know, the other conic sections deal with center. But I'm talking about if I say center when it comes to parabolas, I'm talking about the vertex. But anyway, if this vertex is no longer 0, 0, but hk, and I still have to go a units this way to get my focus, well, I'm going to change the y value to go up. So in that case, the x value is still going to be h, but the y value is going to be k plus a. I have to add a to whatever this y value is to get to this y value. And this should be subtracting a. If this distance is a and this point is hk, then this right here should be subtracting k. And this should be y equals k minus a. So a still represents the same thing. The distance I have to go this way and the distance I have to go this way. It's just not coming off of 0, 0 anymore. It's coming off of hk. Same thing would go if I have a horizontal parabola. Here's my vertex. I go a this way. I go a units that way. And this will get me my focus and my directrix. So if this is hk for my vertex, then if I'm moving horizontally, I'm changing the x value, so the focus should be h plus ak. So the x value gets a added to it. And then same here, the x value gets a subtracted from it, and this would be x equals h minus a. Okay? So that's how we're going to change these parabolas. So if I looked at this equation right here, and I had to find things like the focus and the directrix, I have to recognize this is a parabola because one of my variables is squared. So the y is being squared. If your y is being squared, it tells you you have a parabola that looks like this, a horizontal parabola. So if we look at this, this is in the form of 4a times x minus h equals y minus k squared. So right away I'm going to say my vertex is 3, negative 5. h, k. But it's got to be x minus h, y minus k. So this right here is h, and whatever's being subtracted here is going to be my k, so that I got to do negative 5. Now, from that, I also need to figure out what a is. Well, this number right here is 4a. So that tells me that A equals 4. So since it's a horizontal parabola, I gotta add and subtract the A to get my focus and my directrix. So I'm gonna do it horizontally. I'm gonna change the X. So my focus is going to be 3 plus 4 comma negative 5, or 7 negative 5, and my directrix is going to subtract 4 from the X, and it should be X equals 3 minus 4, or X equals negative 1. So there's my directrix, there's my focus. If you're comfortable working with parabolas centered at 0, 0, or at vertex 0, 0, then it shouldn't be a huge jump to change that vertex to a different location, because everything for the most part stays the same except for the center. Now that last problem was in a very nice form. It was in the form that, our equations typically are in. Here we have a long form polynomial version of a parabola. The problem with this is it's not in the form of 4a times x minus h equals y minus k squared. So what I need to do is put this polynomial in that form, and that's where completing the square comes in. Well, the variable that's being squared is the y, so I want to get all my y's by themselves on one side of the equation like this and put everything to the other side. So first thing I'm going to do is I'm going to write this as y squared minus 6y equals 4x minus 1. Okay, now if you look at what we have here, this looks like some of the examples I showed you previously for completing the square. So if I complete the square, if I write that as a square, I can try and get it into this form. How am I going to do that? Y squared minus 6y plus something squared will allow me to write it as a square. Well, how do I do that? I take whatever this is, divide it by 2, which gives me negative 3, and I square it. That will then let me write this as y minus 3 squared. Now here's the problem. I can't just do that. This is an equation, and on the other side I have 4x minus 1. Well, if I add something to one side of the equation, I should add that same thing to the other side of the equation so that the equation gains balance. So I'm going to add negative 3 squared over to the other side, or 9. So this becomes 4x, negative 1 plus 9 gives me 8. And I'm almost there. At least I have the x minus k squared part done. Now this side has to be in the form of 4a times x minus h. So what I'm going to do is factor the 4 out. So I have y minus 3 squared equals 4 times x plus 2. And now I have what I want. Here's my k, here's my h, here's my 4a. So my vertex is going to be negative 2, 3, because remember it's x minus h, so this isn't necessarily h, this gets me h. This is k. My a value is this divided by 4, so 1, which then tells me that my focus, since the y is squared and I have a horizontal parabola, my focus, I have to add a to the x, and my directrix, I have to subtract a from the x. So my focus is going to be, if I add a, I get negative 1, 3. My directrix, if I subtract a from the x, gives me x equals negative 3. So that's how completing a square can help you with conic sections. So now we look at circles. So our standard equation for a circle is x squared plus y squared equals r squared. That's if it's centered at the origin, which I could also write as x minus 0 squared plus y minus 0 squared equals r squared. There's my origin. There's my center, 0, 0. If I want to change the center, those two numbers should change. So x minus, I don't know, 3 squared plus y minus 4 squared equals r squared. Now the center should be here, 3, 4. So if I change the way I look at the equation to this, then that can help me change where the center is. So now we're looking at circles to be more like this. X minus h squared plus y minus k squared equals r squared. That would be a circle centered at hk with radius r. So if I wanted to look at these particular types of equations, I mean, some questions I could do would be like this first one that says find the equation of the circle with center 2, -5 and radius 4. Well, if I plug the center in here and here and I have the radius, it should be x minus 2 squared plus y plus 5 squared equals 4 squared, or 16. And that would be the equation of that circle. Let me erase some more of this. If we go to the next problem, it's the opposite. In this case, I give you the equation and you need to tell me where the center and the radius are. The problem is this is in a long form polynomial. It's not in this form, so we need to complete the square. But we have 2 squares, so we're going to have to complete the square twice. So what I'm going to do is I'm going to get my x's together. I'm going to get my y's together. And this constant here is fairly irrelevant to completing the square. So I'm going to move that to the other side, so I get -30. So what I'm going to do now is I'm going to look at this as if it was its own problem. Complete the square there. So I have x squared minus 10x plus -5 squared plus y squared plus 6y plus 3 squared equals -30. But that -30 has to have a plus -5 squared and plus a 3 squared added on the end. Because whatever I add to this side, I gotta add over here. So then what do I get? I get x minus 5 squared plus y plus 3 squared equals -30 plus 25 plus 9. -30 plus 25 is -5. -5 plus 9 gives me 4. So now I can say that this is a circle, center at 5, -3 with radius of 2. Because remember, this is r squared. So if that's r squared, the square root of that gives me my radius. Now there's a couple things that can happen here. Remember in the beginning of conic sections I talked about degenerate conic sections. Some degenerate conic sections are points, some are lines. This problem illustrates how those degenerate conic sections could come about. This number is pretty important. It's irrelevant to the completing the square process, which we do over here, but it's important to the problem. If this number right here was, say, instead of -30, say it was what would it be? -34. Okay? Then this would be a -34, and this right here would be 0, because I'd have -34 plus 34. I would get a 0. And that would tell me I have the center at 5, -3, and a radius of 0. Well, what do I actually have then? If I have a center point and no radius, all I have is a center point. So what happens is this particular equation is no longer really a circle because this value is 0. This equation ends up being just the equation of a point, which was one of our degenerate conic sections. Let me illustrate something else that can happen. What if instead of -34, that number on that side was -35? So this is -35. -35 plus 34 makes me get a -1. Now that's really a problem, because if you look at this, this has to be r squared. How could r squared be equal to -1? Well, it can't. Nothing squared could ever give you negative 1. Also, if you look at this, a square plus a square, which means a non-negative value, plus a non-negative value, giving me a negative value, that's impossible. So what happens is this equation isn't the equation of a circle, it's not the equation of a point, this is the equation of nothing. There is not a single value that would satisfy this equation. This equation is never true. So this equation isn't a conic section, this equation isn't a point, this isn't a line, this is nothing. And that can happen sometimes. So doing this process of rerunning these polynomials is important, but also seeing what's happening as you do it. You know, some of these values you get, you got to understand what they mean. Alright, now we have an ellipse. Well, remember ellipse. It was x squared over a squared plus y squared over b squared equals 1. Or x squared over b squared plus y squared over a squared equals 1. If the bigger number was under the x, we called that a squared. If the bigger number was under the y, we called that a squared. And that told us what kind of ellipse we have. Well, we put in this hk like we did the last two up here in the x minus h, y minus k squared. And we got our new center for an ellipse. The a and the b still represent the same thing. The major axis, the minor axis. But now it's that hk changing where the center is. Well, if I have an ellipse that's here at 0, 0, and A tells me how far to go this way, and B tells me how far to go this way, saying it had a horizontal major axis, and I drew my ellipse, I should be able to do the same thing if the center was over here. I still should go A units that way, B units that way, and I can draw my ellipse over here. So that doesn't change, just where the center is changing. The center is now HK. So this problem says find the center, the vertices, the foci of the ellipse for this equation. Again, I'm going to have to do completing the square. So I'm going to take my 4x squared minus 8x, put my x's together, plus my y squared plus 4y, put those together, and then this 8 is going to have to go to the other side. So add 8. Now I'm going to complete the square, but I have a problem here. I don't have a 1 in front of the square anymore. You have to have a 1 as your coefficient for your square. So I could divide by 4, but I have to divide everything by 4, and that would screw up this one, and that I wouldn't have a 1 in front of that one. So instead of dividing by 4, we're going to do what we said. We're going to factor a 4 out. So I get x squared minus 2x plus y squared plus 4y equals 8. Only factor the 4 out of the x's. Now these x's look much better. These y's are already in the form I want. So I'm going to say 4 times x squared minus 2x plus negative 1 squared plus y squared plus 4y plus 2 squared equals 8. But I need to add onto this other side. Well, I added 2 squared here, so I'll add 2 squared over here. Now I added negative 1 squared here, but I'm not going to add negative 1 squared here. I got to add more than that, because I didn't just add negative 1 squared. That's inside these parentheses. So what I really added to this whole thing is 4 times negative 1 squared. So I get 4 times x minus 1 squared plus y plus 2 squared equals 8 plus 4 gives me 16. To put it in the form that we want, we got to get 1 on the other side, so I divide by 16. I get x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. And there is my equation for my ellipse. The center is going to be 1, negative 2. A is the bigger number, so that's going to be 16. A is going to be 4, because that's going to be square root of 16. B is the smaller one, so that's going to be 2. Remember, these are a squared and b squared. So once I have this information here, I can then find the vertices and I can find the foci. So if I want to find the vertices, first of all, we said that I erased it. my equation was x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. We said that the bigger number was here, was under the y, which means my ellipse is a vertical ellipse, right? Because the bigger axis is this way. This axis is 4, this axis is 2. So if I want to find my vertices, I need to look at this ellipse here and say, okay, if my center is at 1, negative 2, and I have to go this direction to get my vertices and this direction to get my vertices, I'm going to be changing the y value. How? I'm going to be changing the y value by a. So my vertices are going to be at 1, comma, negative 2 plus 4, which is 2, and 1, comma, negative 2 minus 4, which is negative 6. My foci are also on that same axis, but they're based off of another variable, c. Well, we still use the a squared minus b squared equals c squared for the ellipse to get c. In that case, I'm going to use 4 squared minus 2 squared equals c squared, or the square root of 16 minus 4, 12, gives me c. So I'm going to say my foci are going to be at 1, comma, negative 2 plus the square root of 12, and 1, comma, negative 2 minus the square root of 12. They're going to be my foci, okay? So I got my center, I got my equation, I got my vertices, I got my foci. Rather than make you find all that information for a particular conic section, you may come across a question like this that just says identify the conic. In that case, they're looking for a couple of things. What kind of conic section is it? And once you identify what kind of conic section it is, discuss what the orientation is it vertical, is it horizontal, where the center is, and some of the other information like what A and B are. So in order to do that though, we need to complete the square. So we go x squared minus 6x plus 2y squared plus 4y equals negative 11. Right away you see a square and a square, so you think, well, it's not a parabola. They're both positive. This is a positive x, this is a positive 2y squared. So now you're thinking, okay, it can't be a hyperbola. So it's circle or an ellipse, and probably because you see a 1 in front of here and a 2 in front of here, different numbers, you might start to think ellipse. Well, we got to be sure here. So I got x squared minus 6x plus 2 times y squared plus 2y. I got to factor that 2 out, so I get a 1 in front of my y squared. Then I get x squared minus 6x plus negative 3 squared plus 2 times y squared plus 2y plus 1 squared equals negative 11 plus negative 3 squared, remember here, plus 2 times 1 squared, because this is really what I added to that side. So I get x minus 3 squared plus 2 times y plus 1 squared equals negative 11 plus 9 plus 2 gives me 0. So then we thought it might be an ellipse, but look at what happened. We got a 0. What does that mean? It means all we have is a point. This is, if I identify the conic section, I'll say this is a point. Specifically 3, negative 1. It's not an ellipse, it's not a circle, it's one of the degenerates, and it's a point. And the last one we got to deal with is the hyperbola. So, if you look at your hyperbola, same as before, the difference is we're introducing this hk. The big deal with hyperbola is we had the minus, that's still the case. A, remember, does not have to be bigger than b. The way we determine what kind of hyperbola we have is not where the bigger number falls, but what variable is in the front part of the subtraction. A still represents the transverse, B is for the conjugate axis. We still use the a squared plus b squared equals c squared to get our foci. All that's the same. So what I'm going to do is I'm going to say identify the conic in this particular one. We want to write this conic in one of our forms. This one's going to end up being a hyperbola form through completing the square. So I go 16x squared minus 160x minus 25y squared equals 0. Put my x's, put my y's together, and I really have nothing else.